Hello, welcome to Apidays. We're on the developer experience track here, and I'm your host or your MC, Alan Kanabe. And with me today we have our first guest. That's Sampo Savolainen from Spatineo. He's a very brave man because he's come here to talk about apps without APIs. So welcome, Sampo.
Thanks, Alan. So yeah, my role here is to be the grumpy old man complaining about all the APIs. Not that I wouldn't use them myself, but to get a bit of a different perspective. So I'm the CTO of Spatineo. We're over 10 years old. We focus on data flows. We focus on data APIs, cloud technologies, geospatial. And we have a SaaS platform that's used for API analytics and monitoring for geospatial APIs. It's called Spatineo Monitor. Now, the thing why I'm the grumpy old man is complexity. Developers have a tendency of adding new layers. We've added complexity over time substantially. I remember when I started doing web development back in way too early, when we had one Perl script, which maybe wrote to a database or to a single file, and we had a plain HTML form which put the data for the Perl script. And of course, that was not optimal. That was horrible. But we've added so many layers that things have become very, very complex. And that has an effect on reliability. And we have to, as developers, I feel that we have the responsibility of considering whether all of that complexity is always necessary. Sometimes it is, but a lot of times it isn't. And we have to think about this when we do design work. And I'm going to present a use case where we were able to do things very simply in an application which you would not necessarily think of being able to implement in such a simple fashion. I'm talking about a case called tuulituhohaukka. For the English speakers, there's emojis. Tuulituhohaukka basically means wind damage eagle, or hawk actually, but the eagle emoji is what's available. There's no hawk emoji. And this was a project done with Aalto Forest Center of Finland and Finnish Meteorological Institute, where they're building an AI model to predict wind damages. And they're using satellite imagery, weather data, forest data, different terrain models, etc., to figure out where in Finland there's wind damages happening. And what we built for this project is a map application for researchers who are developing this model. And it allows them to look at the satellite data, look at the model data, compare these together, look at two different points in time, compare how the map the satellite image changes over time. You can do visual comparison, or you can do time series, etc. And behind this is a huge amount of data. The satellite data is coming from the Sentinel satellites from the Copernicus program, which produces 20 terabytes per day. And even though FMI hosts only the part which is relevant for their work, it's still more than a petabyte of data that's behind this. So there's a huge amount of data. And then we have a relatively complex application, which is though meant only for research use, for a small amount of researchers for occasional use. And there's also then a picture of the time series as well. Now, how do you get this data to the browser? There's of course multiple options, and we were presented early on with a huge amount of different platforms offering data services, etc. But most of them are. I'm looking this from a practical level. How does this actually work? You might have an application server. You have a master storage of all of the data, and you have a local copy on the server. But this is completely impossible. You can't have a server with a petabyte of data for this type of application. That's completely untenable. It's way too expensive. You could do something simpler. You might have a local cache, but this might become very slow. You still need quite a lot of processing power to do this. But really, what's the optimal thing to do here? Would be to have direct access to the data. So have access to an index which tells us what sort of data is there's available, and have direct access to the actual master storage of the data. And of course, this sounds completely crazy and impossible, but actually this is very doable without any APIs. This is done by open standards. We use 2 standards to do this. One of them is Stack, and the other one is COG, or Cloud Optimized GeoTiffs. So basically, Stack is a JSON format for cataloging satellite assets as in images, where things are subdivided into collections and then eventually linked into items and then the actual assets. And then we have Cloud Optimized GeoTiffs. Just to give you a very short overview of what these are. So the way that we build the Stack catalog is a hierarchy. So we have a root catalog, which links to all the different data sets. So this is like different kinds of satellite imagery, or the actual wind damage model or terrain model, etc. And these files contain information that we have data for this amount of time and this sort of bands of data, etc., etc. But those then link to sub-collections which contain, for let's say for a month's period, these are all the images for this month, for that month, and for that month. And then we have the actual items which describe what sort of data there is for this particular time period, and links to the actual files. And this is formulated in a category, in a hierarchy, so that a client can take the root and then figure out, okay, I'm interested in that data set, get information about that data set, and then to go deep down into the hierarchy to actually access the file itself. Now, the files themselves are multi-gigabyte files. They can be 10 gigabytes, they can be even 100 gigabytes. In our case, not that large, but still. So how do you get those into the browser? And that's where the Cloud Optimized GeoTiffs come in. So this is a very handy way of, these are completely standard TIFF files. So there's, even though they are using it in a special way, this is completely standard. You can open these TIFF files in any program whatsoever. There's a bit part, which is an index, which tells you what information is where. And then the data is presented in this pyramid, so that the original full quality data is at level 0, and then it's comprised of smaller tiles. So a client can access only a single tile of the necessary resolution for them. So they don't have to download the entire 10 gigabyte file for them to be able to show what they need on that map. They can choose the right level of detail, choose the right tile on that level of detail, and get that. And this is possible by HTTP GET range queries. And this is a really basic technology that has existed for 20 years, more than 20 years. But it's one of those things which is underlying everything, all the stacks that we do in all of that complex infrastructure that I talked about earlier. And that's on the bottom of everything, and that's usable almost universally everywhere. And this allows for highly efficient data collection or getting the data to the browser application. So what does it actually look like? How does it work? So this is a very quick demo of 2 side-by-side maps. You can see that they're synchronized. I'm zooming into the satellite imagery, and the images are updating very quickly. And this application is reading the Stack catalog and reading those GeoTiffs and producing this image on the map. And all of this is relatively easy to implement, and nothing requires anything special. So this looks just like Google Maps. It looks like anything else that you might see as a map application. You wouldn't know that there's this sort of simplicity magic going on behind there. To just show off what the application can do, you can also, because this is a professional application, you must be able to choose different data sets. Here we're taking the wind prediction model as a view. It's a bit of a boring picture, but you get the picture. We can look at different bands of the satellite, because these optical satellites aren't just looking at red, green, and blue. They're looking at the wide range of frequencies of optical light, and you can choose the different visualizations and zoom based on that, and look at the images based on that. So this offers a large variety of possibilities for professional users to access the data, even though there is no server behind this. except for an HTTP server. And then to show off also the time series capability, forgive me, this is in Finnish, but this then works by looking at the catalog, looking at all the assets that there are, and downloading only a small bit of information from each of these files to produce the time series. And now you can see a lens. We chose a comparison date, and we can run this lens over this image to show a different time of the satellite image. And you can see that that's synchronized for both views. And the main point here is that this allows the researcher to look at whether there is differences in the satellite images in places where the machine learning algorithm has detected a high probability for wind damages, and they can see whether those wind damages actually happened. And this allows for developing the model methodology, etc. So looking at the actual metrics of what's going on here. So I looked at what data I accessed during that demo when I recorded those. And there's, first of all, the left-hand side in the original picture was Sentinel-1. That's radar satellite images. So there's actually 2 images being used, or 3, but in most cases 2, but they're 10 gigabyte images. And those were accessed real time, very quickly to the browser. The optical imagery, they're very small compared to, or smaller compared to the Sentinel-1. There's 1 gigabyte. The model output is really small. But then when we had the time comparison tool, everything there was doubled. And then for the time series, there were actually 20 time steps. And those time steps were retrieved from not 20, but 60 different images, because each band is in a different TIFF file. So actually the total amount of data there was 100 gigabytes. But then I used Chrome DevTools, and I disabled the cache entirely and looked at what was actually being transferred. And it was about 250 megabytes. Sounds like a lot, but compared to 100 gigabytes, that was quite less. And then you have to remember that when I had the cache disabled, it also means that the browser keeps re-downloading bits of data that it already downloaded during that session. So it's not even giving, like, probably the right number would be slightly lower than 250. It's still a lot, I agree, but it's still very, very quick for what it is, and especially without a server. So the key takeaways here is really to keep it simple when possible. This is a really important point, and I think this is something that developers nowadays are in a very large danger of missing out. We have as I said earlier in the beginning, is that we have the tendency of adding more stuff in. We need to think about taking stuff out, or not putting those things in, but making it simpler. And you can do a lot with just HTTP, and then think about what you can do with all of the technology that is available for us at the moment currently in the market. We can do a lot of stuff for them, with them, not just the stuff that's sort of printed out on the box. There's less code here. There's no server, so there's less maintenance, and there's less cost, and there's one point of failure less than there would be, and that's a very large point of failure, because think about what we are actually using to produce this is basically an S3 service. It's an open source Ceph tool which is producing the S3-like service, but it's the service that FMI needs to be running anyway for all of its other functions that it uses the satellite imagery for. So that service is rock solid. That is not going anywhere. And you can build the same thing with the actual S3, and you know that AWS's S3 never goes down. So building something like this on top of that infrastructure will be highly, highly reliable. And as you saw, this was very fast. It does require more bandwidth than like a specialized service using standards such as WMS or WMTS, where the client really just requests, I'm interested in this bounding box of data, give me that. It will be more bandwidth. It will save a lot of bandwidth, but this is still, considering our current access to broadband connections, this is really quick. And then from a data management point of view, there's no extra replication. There's no caching involved. Everyone knows the old quote that there's only two things difficult in computer science: naming things and cache management. So this is an important point. And then standards. This is really standards-based work. There's great standards that we're using. We're using the stack standard. We're using the cloud-optimized geotiffs, and that allows us to very efficiently use already made tools like OpenLayers, which can immediately load those cloud-optimized geotiffs and know where to place them on the map. They know the resolutions. They know everything about that. And also getting the time series data using geotiff.js was very, very simple. And of course, what we built here for this sort of a research application, end user application, we also built the catalog, and that catalog is usable in many different places as well. So it's this, because of standards, this is not just built for a small research tool, but also usable elsewhere. And that's really it. That's my short story on why we need to think about complexity, try to avoid it when possible. And I hope I was able to sort of at least inspire some of you to think about what can we achieve without all those fancy new technologies that are being pushed on us, which have their uses. I'm not that grumpy, but sometimes simple is nice.
Right. I like the way you describe, you describing APIs as being fancy and new, because I think they've been around for like 30 years or something.
Yeah, they have. Actually, these geospatial APIs that I mentioned, the WMS, those were introduced at the same time as people say that sort of web APIs became a thing.
Right.
So our field has sort of been one of the originators of the whole idea. In a sense, of course, APIs have been around for longer, if we then consider APIs as like software interfaces. But
okay, and was it, so maybe I missed it at the beginning, but did you try to use those APIs and then you failed, right? It was the performance wasn't good enough.
No, we knew from the start that it wouldn't really make sense. We knew that we would be building infrastructure which wouldn't make sense for the customer and for ourselves to maintain, because as mentioned, the amount of data from satellite imagery is incredible.
Right.
And it's also being proven as a very valuable resource. We're seeing more and more people taking advantage of them and building APIs that, like, I don't remember the name of the company, but there was a German company that's producing APIs which help leverage the satellite imagery, so that you can build models and algorithms on top of the satellite imagery, and then have an API where you can get sort of the crunched data out of the images, not look at them as pictures, but get the relevant information out of there.
Interesting. Do you think it's so that in the API space we're missing somehow the support for crunching of such large data files? Is there something we should be working on to make it easier for people to work with APIs in this space?
Well, I think there's quite a lot of movement towards that, but it's still sort of early stages. For satellite imagery, there is the European Commission has mandated member countries to use satellite imagery to control things like agricultural subsidies, and there's being built platforms that help use the satellite imagery to produce that information. So basically checking whether farmers are actually farming what they're saying that they're farming and getting subsidies for. And those are turning into more data products and not image, sort of nothing that people are looking at, but actually getting the relevant information into their business processes.
Okay, I see. So it's more or less a split, right? So using APIs as for the product part over the top of it. But what you're saying is that fundamentally the core infrastructure, you need to get clever on how that is. But the question is, like, if you're with an API, okay, I guess we think of them as being standard. Developers know how to use them, and from a developer experience here, how is it with like doing this as a standard thing, right? So you've done something quite quite custom, and you say, okay, keep it simple, but is what you've done actually quite complex?
Well, it is based on standards. So the stack standard is a not more than just a de facto standard. It's published. It's open, sort of open common standard. And the cloud optimized geotiffs is a very similar standard as well. So I would say that it's not custom in the sense that the work that we've done can be a platform for others to build applications using the same data. But of course, it's custom in the sense that we were working on the use case that the researchers developing the AI model had. So to sort of be able to browse the information in an efficient manner to understand whether their algorithm is working well or not, or if there's corner cases that it's failing at, or something like this.
Okay, I see. And again, coming back to developer experience, if a developer wanted to get started, how would they do that? I mean, do you have the equivalent to a developer portal?
There's a lot of discussion over the stack specification, for example, and that specification is being used quite widely in the sort of Earth observation scene. So most of the satellite imagery that's available is somehow accessible through these stack standards. And also, I think one important thing, maybe I'm focusing too much on the satellite imagery, but I think it's pretty cool that the Sentinel program is actually producing open data. So the imagery produced by the European satellites is free for everyone to use, and they're actually imaging the entire globe at least every 5 days. So there's a huge possibility there, and the fact that the data is produced openly and accessible using these sort of standards makes it, well, it doesn't necessarily make it easy to use, but it's an important step on getting useful information out of that data.
Well, it's a huge amount of data then. I mean, if it goes around, if you say, okay, just those two files were how many gigabytes? Like 10 gigabytes, was it?
Yeah, and that was for one channel.
Wow, you can imagine the data. And so who's supporting that initiative then?
Well, it's ESA, European Commission, member states, many EU agencies, and then also AWS is one partner. So AWS is actually hosting not all of it, but most of the data, and they're offering it. Some parts of it are offered by AWS completely for free, and some of them are offered so the requester pays method, so that you have to have an AWS account yourself. You pay for the S3 usage for accessing the data, but of course that's pennies compared to what actually producing the data has a cost for the entirety of Europe.
Wow, I mean, it's really cool, but I can just imagine an entire data center just stacked up with this stuff.
And imagine the truckloads of storage drives that are being sort of sent to these data centers on an ongoing stream.
Right. Yeah, that's
because it just keeps growing.
Yeah, I can imagine. So just to round off on a more of a less grumpy, more API positive sort of thing. What has been the best API you've used in the past? One that you really love to use again?
Curveball.
Yeah.
I have to say that I've been disappointed by some APIs recently that they haven't provided the sort of functionality that I would like to, and then end up sort of fixing it after getting too much data. Some of the best APIs, well, maybe it's a simplistic or given answer, but I think CDK, CloudFormation for AWS, is still it's such a key piece of infrastructure nowadays, and the fact that we're able to control such a complex beast as AWS using code and using APIs is pretty incredible, and what that allows for developers to do compared to the old days. So I was talking about the old Perl scripts and etc., which hopefully no one else here has had to do. But compared to that we can spin up servers, we can spin up managed databases or CloudFront distributions with just a few API calls and use that to build our applications is incredible. And that's definitely something that I'm not grumpy about. Quite the opposite. I'm advocating our customers to look more and more into that and helping them get the most out of the possibilities of the modern world.
Excellent. Good less grumpy answer. Thank you very much, Sampo.
Thanks.